Alright, so worked example 10 for the weighted network below. We've got to find the capacity of each cut set and the capacity of the minimum cut set and maximum flow through the network. To make sure we can do that, we got to remember the three rules that we have on this side of the page. So, we got to make sure the network is weighted and directed, that there is no inflow and there is no outflow. All edges are connected from the source are leaving the source, all edges connected to the sink are entering the sink. So we go back to the diagram. We have a weighted and directed network. Doesn't show inflow or outflow. All edges connected at the source are leaving the source, as by the arrows, and all edges connected to the sink are entering the sink. So those three requirements have been met. So now we can find the capacity of each cut set. So to do that, we make a cut at source A to start with. So capacity at cut A is the three edges leaving A. So we're going to add 4, 2, and 6, that gives us 12. And we're going to do that for each of the other next cuts. So if I move down the page, here we've got the capacity of A and B. So it's all edges leaving that vertex without it going, and it cannot flow from one vertex to the other if they are the vertexes we are looking at. So here we can consider AD, AC, BC, and BE. We can't consider AB because we are looking at the capacity of AB, and we need to look at edges leaving that cut, highlighted in circled in green. So we're going to add 6, 2, 3, and 5. That gives us 16. So we're going to keep doing that for the next few cuts. Alright, so the next one we consider A and C. So again, leaving A, leaving C cannot be directly connected to between A and C, or going from B to C. It's just ones that are leaving A and C. So leaving A we got 6 and 4, that's 10. Leaving C we got 7, there's your 17. If we consider A, B, and C, same thing. Cannot consider any edge that is leaving A, B, or C connected to those edges. So we can consider 6, 7, and 5, but these three we cannot connect as they are moving to our vertexes that we have identified. And so you go on and do that for ACD, same thing. And then if I move down the page, they've considered A, B, C, D, and E, and so on. Again, A to E, same thing, only the ones leaving those sources. ACE, again, leaving those vertexes. A to D, leaving those vertexes. Once you've done that, you come to this group of 16 combinations of letters, A, B, C, D, and E. Each combination has a cut capacity. So these are all the ones they've considered. The question in part B says we need the minimum cut set and maximum flow through the network. The maximum flow equal to the weight of the minimum cut. So that means the minimum cut, which means the smallest cut that we have, will be equal to our maximum flow through the network. If we go down through this list, you can see that the minimum is AD, which is 10. So that is the weight of the minimum cut set. That means here they've said the minimum cut set, which is equal to your maximum flow, is AD with a capacity of 10.